Hello, check this out. This is an Agilent E4400B signal generator. I picked it up on eBay for a reasonable amount of $200 plus $40 for shipping, and all I know about it is that it must be complete, no missing parts. It powers up, it boots up, and something is wrong with it. I'm not sure what exactly. Let's have a look. Alright, I plugged it in. Let's power it up. There you go. What do we see? Error 514, reference oven cold. This is not a problem at all. This error means that the precision frequency reference, which is OCXO, or oven controlled oscillator in other words, was not warm at the time of boot up. So this thing keeps it warm while plugged in, but if you don't plug it in for a while, then first time you do, it shows this error. After the oven warms up, we can clear the error and it should be fine. Let's see, how do I clear this error? There you go, error info. Oh, here is the problem. Frac N loop unlocked. I believe it must be about PLL in the synthesizer. And this is error 1 of 2. How do we get the next one? Next error message. Yeah, that's the error we've seen about the oven, which is not a problem at all. Okay, let's try clearing the error. So now we have this one. Alright, let's have a look at the scope. I have this adapter from N connector to BNC. And let's use channel 4 because it's a short cable. Okay, so now let's set lower frequency because this is a 5 megahertz scope. Let's start with 100 megahertz, let's say. Enable the output, and the amplitude is very low now. Let's go up. Alright, so we see something. Where is my trigger? Oh, trigger is on channel 1. Okay. This must be aliasing. Oh, there you go. Let's measure frequency and amplitude. There you go, 100 megahertz, 238 millivolts. Looks fine on the first glance. Let's Increase the amplitude a bit, it works. Let's increase the frequency. Well, it's gonna take forever. Let's do this 200 megahertz. Oh, there you go, 200 megahertz. So it works. Well, let's go to 500 megahertz. This worked as well. Now we are pushing the limit of the scope. Oh, look at this. Something is wrong here with the frequency measurement. I'm not sure if it's the scope or perhaps that problem with PLL. You see, I just saw unlock message here appeared and disappeared again. So this output frequency might be not stable. And you see it's jumping all over the place here. But it might be a scope's fault. So let's fetch the counter. This counter cannot go higher than 225 megahertz. So I set 200 on the generator and it looks fine. Let's try 100 now. This works. Let's try 50 megahertz. This worked as well. So perhaps the problem is intermittent. I'm trying to play with the thing and in particular trying to see the limit of my counter. It's supposed to handle up to 225 megahertz, but I set the generator to 300 and it still works. Let's see, 350 works, 400 still works, 500 still fine, 600. Oh, there you go. 550. Now back to 500. 500 works. Let's push the limits of the scope. We are at 500 megahertz, which is supposed to be the limit of the scope, but let's go higher, 600. Well, at least the frequency measurement is all over the place. Let's go even higher, 700. That's a mess. So let's start taking it apart. This is the back of the unit, and there are two Agilent stickers and they are broken, so someone has been inside. Cover off, and it is completely shielded. I removed the top shield and I see a lot of room for extensions. 4 slots here and 2 slots here. Well, perhaps this slot is taken. Someone made some notes on the side shield. Is it bulk R or something? Lock angle. Here I removed the side shield, and there are 5 slots and 3 boards here. I looked them up. This is the synthesizer board. This is the frequency reference OCXO board, and this is the output board. Have a look. There are 10 LEDs on the main board, and I believe they are showing the status of the power rails, which are marked right next to the LEDs. The first one is plus 5.2, then plus 12, then plus 32, then minus 15, plus 15, and so on. So this means that most probably the power rails are fine. Here I removed the shielding from the bottom of the unit, and I found test points on the board for the power rails. So I measured the power rails and they seem to be fine. Here are the RF boards. This is the synthesizer. This is the output board, and this one is the frequency reference board. Here we see the 10 MHz OCXO sticking out. Unfortunately, I couldn't find any service manuals or anything like that so far. I suspect this unlock problem must be in the synthesizer. Here is the synthesizer board. And here is the other side. Look at these markings on the board. It seems like this synthesizer is capable of doing 4 GHz. Perhaps the same board is used across the whole line of products. Here is VCO, and this package is LM355A, which is temperature sensor. This is a buffer. This is a clean power supply for the synthesizer. And this big section is marked FM here and SDFM here. This section in the corner is also marked FM, and it has 2 adjustments and a jumper. This adjustment is marked F/2, and this is marked LA, which is lock angle. This is the reference board. Nothing on the other side. Some sort of modification here. Do you see that the flux was not really cleaned up here after the soldering? I wonder why. And same thing here on all through-hole components. Here and here and here, here, here. And this is the output board. And look at this modification. Two pins are lifted up here and the wire is added. Is this a power reference? The amplifier is bolted down to the chassis. I don't want to disturb this. Sorry, no look at the other side of the board. I found the block diagram for the synthesizer board. Let's have a look. Here we have main fractional PLL synthesizer. The reference input is here, 10 MHz from the reference board. It gets divided by 2, and the 5 MHz reference goes to this phase detector, the output of which goes through this loop filter, and the resulting voltage is used to tune this voltage controlled oscillator. It produces from 500 MHz to 1 gig. The output goes through a couple of buffers. This is for the feedback. This is divided down to 5 MHz to compare with the reference here in the phase detector. And this output goes to this block. Here it can be divided by 2. Then we have band pass filter. The next block we can go through it or we can bypass it. So this is the first doubler. This is the second doubler. So the output of the synthesizer can be multiplied by 4. That's how it can produce 4 gig. And here's the output buffer and such. And this is the frequency modulation block, and plus some supporting circuitry and such. So let's compare it with the board. So I traced the reference input from this connector to this section. So here we have this divide by 2 thing and the phase detector. Then the output goes to this loop filter, and here we have these 2 adjustments. This one is VCO bias, marked here F by 2, and this is lock angle adjustment, this thing. Then we have this out of lock detector, and here is red LED to indicate the out of lock condition. Then here we have a tune test point. This is the tuning voltage for this VCO. The output of VCO goes to this section marked buffer here, and here we have test points for the buffered RF signal. And the output of this buffer must go to this fractional divider, which goes to this phase detector, which closes our loop. And here we have this divide by 2 section marked here on the board. Then we have this band pass filter, then first doubler, which is this section, then this second doubler with band pass filters. So this part is second doubler and some band pass filters here. This is another filter here, and the output amplifier. And this big section is digital control, controlling the division factor and doing this frequency modulation and such. And this is the power supply, providing quiet power rails for all this stuff. I put the synthesizer board into the unit with no cover on it, just to see what happens. Let's power it up. You see the unlock LED is on when the unit is powered up. And it goes off when the unit boots up. It was running like this for quite a while, and the unlock error did not come back yet. I suspect that someone messed up the adjustments, and I'm afraid I cannot really adjust these things properly because I don't have a spectrum analyzer. There is a section in the calibration guide regarding this adjustment, and the spectrum analyzer is necessary for this procedure. They also propose to measure voltage at some point and adjust potentiometers so that the voltage is within this range, but I'm not quite clear where exactly this should be measured. I suspect that this is about some reading in the service software, which is mentioned here, and the software is available on keysight.com, but a Gpib interface card is necessary for this, which I don't have. I think it's time to buy one. I needed one a few times lately for different reasons, so I think I should buy one of those fake Agilent USB to Gpib adapters, which are sold from China all over eBay. Here is the next step: a lock angle potentiometer after that VCO bias adjustment is done, and the spectrum analyzer needed here as well. I hope you enjoyed the look into this fine instrument. If you did, give it thumbs up and subscribe to the channel. Thank you very much for watching. Bye!